Light travels 1.8 times 10 to the 7th kilometers in 1 minute. How far does it travel in 9 minutes? Write your answer in scientific notation. So here's what it is in 1 minute, but I need 9 of them. So what we have to do is we have to take our speed or our rate of 1.8 times 10 to the 7th times or multiplied by our time. So we need to take 9 minutes times 1.8 times 10 to the 7th. Now people instantly panic, like, Miss Hopp, how can we do this if 9 is not scientific notation? Well, 9 is like your factor, your coefficient out front. So really we need to multiply these two together. 9 times 1.8, 16.2 times 10 to the 7th. Leave it as time 10 to the 7th. Okay. Yesterday we all would stop and ask, and I would say, can we circle this?
No.
Why not? There's 2 numbers. How many do you really want? 1. Okay, dash diagram. Dash diagram. People got cocky yesterday, and it's going to bite you even harder today. You have a positive 7 exponent, which means there's 7 dashes to the right. So I have a decimal with 1, 2, 3, 4, 5, 6, 7 dashes. In 16.2, what am I going to do with that decimal? Move it to the left 1. So in our dash diagram, we move it to the left 1. What do I do in that open swoop? Add a dash. My answer ends up being 1.62 times 10 to the 8th. 8 dashes to the right-hand side. 8 dashes to the right-hand side. And some of you are like, Ms. Hoff, I have that down pat. Problems that stumped people yesterday, and I didn't put one on here, so I'm going to do it right now. Underneath this, write this problem down. 6.89 times 10 to the 4th plus 9.24 times 10 to the 5th. What is this problem asking us to do? Add. What is important about addition and subtraction with scientific notation that's different than multiplying and dividing? Bingo. The very start, nicely done, Aspen. At the very start, we have to double check our exponents are the same. Currently, what exponents do I have? 10 to the 4th, 10 to the 5th. Which one do you want to change to? 4. Okay, so we are going to leave 6.89 times 10 to the 4th. Does it technically matter?
No.
No, somebody could switch them to the 5th, so you're going to end up with the same answer. Okay, so on my dash diagram right now, I have 1, 2, 3, 4, 5 dashes to the right because it's a positive 5. How many do we want to have? 4. So what am I going to do with my decimal? I got to move it to the right because this guy goes away. Whatever you do in your dash diagram, we do your number. So we move it over. 9.24 becomes 92.4, and now it's times 10 to the 4th. Now, as Aspen said, whoopsie, sorry, wrong marker. Now that these are the same, we can regroup them. We can put our front pieces together. 6.89 plus 92.4. That was a common mistake yesterday. People wanted to change that to multiplication. And we're going to keep it as times 10 to the 4th. So now actually add 6.89 plus 92.4. 99 point, like that. Okay. Times 10 to the 4th. Can I circle it? On your own. Move this decimal for me. I'll check in with you in just a second. On your own, get this in proper scientific notation. Right now I have a 10 to the 4th. To get my 99, I really only want one number in front of there, so I'm going to move it to the left. I move my decimal to the left. That open swoop causes another dash. So I end up with 9.929 times 10 to the 5th power. Adding and subtracting, make sure you match your variables before you add or subtract. All right, flip it over. What are you doing on this one? Multiplying. How do you know? You're right. How do you know? Parentheses are in all of them, though. They're right beside each other. Very good. So this tells me there's no plus or minus sign in there. We're multiplying. So with multiplication, we get to regroup right away. We're going to put 7 times 6.6 together. And we're going to put 10 to the negative second and 10 to the negative 6 together. What do you do with those first two numbers? You actually multiply them. 7 times 6.6. 46.2. What do you do to your exponents? Keep my base of 10. Negative 2 plus negative 6 is... Now, what is different about this problem than what we did yesterday? It's a negative exponent. Don't let that change what you're doing. It is going to change our dash diagram, though. Everybody agree we got to adjust this because I have a 4 and a 6, correct? With a negative exponent, technically you're moving to the left, yes? So now your dashes need to be to the left of the decimal. Still 8 of them, but on the left side. 1, 2, 3, 4, 5, 6, 7, 8 dashes on the left side of the decimal. Follow me? Because it's negative, we're really moving to the left. In 46.2, what do you want me to do with that decimal? Move it to the left, yes? In your dash diagram, move it to the left. What happens? That one goes away. So I have 4.62. Now, how many dashes are remaining? 7. Which side of the decimal are they on? So what does that tell you about your 7? It's a negative 7. So today, as many of you felt so confident with moving that decimal yesterday, I'm going to throw you a curveball because you also have negative exponents, which are a little bit different. You follow the same process, but different things happen to that exponent. All right, what's the next one doing? Dividing. So we separate them off. 7.2 divided by 8. 10 to the negative 5th divided by 10 to the 6th. What do I do in the first one? We actually divide. 7.2 divided by 8. 0.9. What do I do to my exponents? Now watch your integer rules. Negative 5 minus 6. Negative 11. Negative 11. Can I circle it? Try to change that on your own once. Adjust that exponent for me. Oops. 11 dashes, but because it's negative, they're to the left of the decimal. Now, I need to move my decimal to the right. Agreed? So when I move this to the right, what happens in that open space? I add another dash. 9 times 10 to the negative 12th. Count your dashes. When I had to put another one in here, this number's getting bigger, yet really it's a negative, so it's getting smaller. But anyway, you're adding another dash. There's more movement here. So the biggest frustration people have had is forgetting that adding and subtracting, we got to make sure we have them the same exponent before we do anything, but also that negative. Okay, so just really pay attention. Last one, ready? Galaxy A has 2 times 10 to the 9th stars. Galaxy B has 8 times 10 to the 6th. Choose which galaxy has more stars, then fill in the blank with a number written in standard notation. How would I ever determine if galaxy A or B is bigger? I don't want to go to standard form. How can I determine if 2 times 10 to the 9th or 8 times 10 to the 6th is bigger? Very good. Bigger exponent, bigger number. So rule number 1, bigger exponent equals bigger number. Bigger exponent equals bigger number. So if I have 2 times 10 to the 9th and 8 times 10 to the 6th, is galaxy A or B bigger? A, because you have 10 to the 9th. So I'm going to box this in as my choice. Step number 2 then, if we want to figure out how many times bigger it is, take the big galaxy divided by the little galaxy. Take the big divided by the little. What number represents our big galaxy? What scientific notation represents our big galaxy? 2 times 10 to the 9th. And what represents my little galaxy? 8 times 10 to the 6th. So we split them apart. 2 divided by 8. 10 to the 9th divided by 10 to the 6th. Say it again. 0.25. What do I do to my exponents? 9 minus 6 is 3. Now pause for a minute. This is the only problem this occurs on. Fill in the blank with a number in standard notation. Standard notation is the expanded. That's what we did on Monday. Remember, your exponent tells you how many swoops to make and which direction. How many swoops am I taking? 3, and which direction? How do you know it's to the right? Because it's positive. Okay, so I have 0.25. Move your decimal 3 swoops to the right. 1, 2, 3. Now my decimal's out here. What do I put in that open blank? 0. So I have to fill this in. Galaxy A has 250 times as many stars as Galaxy B. Today, the twist, if you want to say, is just that there might be negative exponents. Don't change your rules. Okay, fold your hands for 1 second before I turn you loose. Okay? You guys have done really well with homework. Last Thursday's review was a little shaky, but overall you've done really well with homework and focus and attentiveness, and I really appreciate that. I can see that in what you're doing and your conversation with me. So today, I think it's 10 problems. I'm not positive. Maybe it's 9. I can't remember. You have an online assignment 1-7. When you get done with that, if you get done with it in class, as soon as you get done, an optional online review will open. I am not assigning it, but it's there for you. Tomorrow we will do a paper review, and Friday you have a test. But some of you want to get that grade up, like, oh, I'm going to falter a little bit. I want to score as high as I possibly can on this test and raise my grade as far as I possibly can. And part of that is just repetition and practice. The whole front side of your test looks exactly like your quiz, guys. Identical. The same rules, all those exponent laws. So some of you did really well on your quiz. You just have a couple things to fine tune. Others of you are like, oh, crud, I got to study that again. So that optional online review, even if you do it for 15 minutes tonight and 15 minutes tomorrow, you will see a world of difference in how you score on Friday. Okay? Totally there for an optional, not graded, there for extra practice. Cool? The hour is yours. Go to it. Ask me if you need help.